Hello, my name is Calvin Ng from the University of Alberta, and today I will be introducing work done by myself and Abram Hindle on mining insights from Dockerfiles to understand Docker usage over time. So the motivation behind our work stems from the release of Docker in 2013. In about 7 years' time, there have been 2.9 million desktop installations of Docker and 7 million Docker Hub users. This suggests that Docker is ubiquitous with the containerization of applications for deployment and development. The significant amount of users makes understanding how Docker is used interesting to investigate. Analyzing Dockerfiles is not new. However, previous work on analyzing Dockerfiles has focused on smaller and older data. To obtain the Dockerfiles for our dataset, we used a world of code infrastructure that contains open source software code from sources such as GitHub, GitLab, and Bitbucket to obtain over 9.4 million Dockerfile blobs with valid instructions, over 11.5 million unique commits linked to the blobs, and over 1.9 million distinct repositories. This data spans up until December 2020. Distinct repositories are the most central repository to represent a group of repositories linked by commits, found with the Louvain community detection algorithm. It helps to avoid clones of projects, also known as forks, when performing an analysis of projects. From our dataset consisting of over 9.4 million Dockerfiles, we find, in regards to how many Dockerfiles that are typically used in a project, approximately 95% of distinct repositories contain around 2 Dockerfiles, and approximately 1% of distinct repositories have 7 or more Dockerfiles. In regards to Dockerfiles being cloned and used, only 8% of Dockerfiles exist in more than one distinct repository, and the top 10 most cloned Dockerfiles are being used to build software or are being used as a base image to run specific software. Finally, we find that Python and JavaScript are popular languages of code run in Dockerfiles. This is comparable to results found in prior work. We also revisit the analysis of Dockerfiles over time and find some insights that have not been discovered in previous work. For our first research question, how are instructions and base images used in Dockerfiles over time? One insight we find is that following the introduction of the copy instruction, add instruction usage has decreased over time while copy instruction usage has increased. In our second research question, how prevalent are code smells in Dockerfiles? One observation we see is that version pinning to reduce dependency issues is still a major problem that has actually been increasing over the years, something not found in previous studies. For our third research question, how do Dockerfiles change over time? One thing that we confirmed by replicating the method of a previous study is that over a longer period of time, from 2013 to 2020, is that there is a trend of small changes and decreasing revisions of Dockerfiles. So I will conclude with the implications from analyzing our Dockerfile dataset. To support software developers who might use Dockerfile, you should make images lightweight for speed and have version pinning for reliability. To support developers that write Dockerfiles, Dockerfile writers should be aware of the potential pitfalls of using certain instructions or techniques. Therefore, they would benefit from better tooling and education. For the maintainers of Docker, our dataset allows for them to observe the effects of deprecation efforts as well as tracking the usage of new features. For example, they can see the decrease of using the add instruction after the copy instruction was introduced. And also from Dockerfile smells, they can identify what tooling and education might be needed and developed to help better support Docker users. Finally, the dataset and code of our paper has been released to encourage more replication and to support open science. Thank you.